point of procedure to trace Cartesian curve, it is asymptote. What is exactly asymptote? Asymptote, it is not a curve. Asymptote, it is a line which touches the curve at infinity. So therefore I have written asymptote, it is a tangent at infinity to the given curve. So definition of asymptote is a line which touches the curve at infinite distance. Now there are three types of asymptotes. One is asymptote parallel to x-axis, asymptote parallel to y-axis, and the third type it is oblique asymptotes. Now how to get asymptote parallel to x-axis? To get asymptote parallel to x-axis, equate the coefficient of highest power of x to 0 from the given equation, provided that coefficient should not be the constant. Once again I will repeat. To get asymptote parallel to x-axis, equate the coefficient of highest power of x to 0, provided that coefficient should not be the constant. Similarly, to get asymptote parallel to y-axis, equate coefficient of highest power of y to 0. For example, if I take f of x comma y is equal to x square y minus x is equal to 0. Now we will check whether for this curve asymptote is present. So to get asymptote parallel to x-axis, equate coefficient of highest power of x to 0. So here highest power of x is x square, its coefficient is y, and therefore y is equal to 0 is an asymptote parallel to x-axis. Now to get asymptote parallel to y-axis, equate coefficient of highest power of y to 0. Now in this equation, there are two terms in which y is included and y is having same power. So here highest power of y is 1. Then what we do in this equation, I will take y common. So what it will remain? Y into bracket x square minus 1 and then minus x is equal to 0. Now what is coefficient of highest power of y? The coefficient of highest power of y is x square minus 1. Now put this x square minus 1 is equal to 0. This implies x square is equal to 1 and this implies x is equal to plus or minus 1. It means there are two asymptotes, that is x is equal to 1 and x is equal to minus 1, which are parallel to y-axis. So for this curve, there is one asymptote parallel to x-axis and there are two asymptotes parallel to y-axis. Now, if we consider second example, that is f of xy is equal to x cube plus y cube plus 3axy is equal to 0. Now to get asymptote parallel to x-axis, first find highest power of x. So here highest power of x is x cube, but its coefficient is 1 and 1 is a constant. Similarly, to get asymptote parallel to y-axis, find highest power of y, that is y cube, but again its coefficient is constant. So if the coefficients of highest power of x and highest power of y are constant, then asymptotes parallel to both the axes are absent. So asymptotes are absent for such curve. Now the third variety of asymptote, it is oblique asymptote. And oblique asymptotes, it means these are the asymptotes which are not parallel to x-axis, not parallel to y-axis. So these asymptotes can be given as y is equal to mx plus c, because in beginning itself I told asymptote is a line which touches the curve at infinite distance. So oblique asymptote is represented as y is equal to mx plus c, where this m is calculated as m is equal to limit x tends to infinity y upon x. So y, it is given quantity, and then divide that by x and take its limit as x tends to infinity. And value of c is limit x tends to infinity y minus mx. Value of c is obtained from this equation. So value of c is y minus mx and calculate it as x tends to infinity. For example, if suppose we take y is equal to x square plus 2x minus 1 divided by x. Now to get asymptote for this curve, let us check whether this curve have asymptotes parallel to x-axis and parallel to y-axis. How to check? Now x square upon x power is 1. Here x will get cancelled, and here x raised 1 upon x is nothing but x raised to minus 1. So which is the highest power of x? It is x. What is its coefficient? It is 1. But coefficient is a constant, therefore asymptote parallel to x-axis is absent. Similarly, the highest power of y, so y is present only in one term. So what is highest power of y? It is 1. What is its coefficient? It is 1. So if coefficient of highest power of y is constant and therefore asymptote parallel to y-axis is also absent. It means for this curve there may have oblique asymptotes. Now to get oblique asymptote, what we do? We calculate m, we calculate c, and we will substitute here. Now for given curve m is equal to limit x tends to infinity y upon x, but y, this is the value, so y upon x it will give us x square plus 2x minus 1 upon x, and again divided by x it will give us x square, and then you calculate its limit. So limit x tends to infinity, here it is 1 plus 2 by x minus 1 by x square. Well, x tends to infinity, so these two terms tends to 0, so the value of m is 1. Similarly, what is the value of c? The value of c is limit x tends to infinity y minus mx. So what is the value of y? X square plus 2x minus 1 upon x minus mx, but value of m is here, value of m is here 1. So 1 into x, it is x. And when I simplify this is nothing but limit x tends to infinity. Now if I take LCM, then I will get x square plus 2x minus 1 minus x square divided by x, and this will give us limit x tends to infinity in bracket. So this x square and this x square will get cancelled. So 2x upon x it is 2 and minus 1 by x. So 2 minus 1 by x. But as x tends to infinity, this second term tends to 0. So the value of c is 2. And therefore the oblique asymptote is y is equal to mx plus c, but value of m is 1. So 1 into x is x plus value of c is 2. So this is the oblique asymptote for the given one. Is it understood? Okay. Part of oblique asymptote is oblique asymptotes when f of xy is equal to 0 is an implicit function. So first of all, I will give definition of implicit function. The implicit function are those, these are in the form of f of xy is equal to 0, in which we cannot express y totally in terms of x, or we cannot express x totally in terms of y. For example, if suppose f of xy is x cube plus y cube minus 3 axy is equal to 0. So in this equation, we cannot separate y and x on both sides. So here we cannot express y in terms of x, and also we cannot express x in terms of y, and therefore such functions are called implicit functions. So if such implicit functions are given, then how to find asymptotes or oblique asymptotes? So the oblique asymptotes for such functions are given as y is equal to mx plus c, where m is a solution of phi n of m is equal to 0 and C is equal to minus phi n minus 1 of m divided by phi dash n of m. But what are these phi n of m and phi n minus 1 of m? So phi n of m and phi n minus of m can be obtained by putting x is equal to 1 and y is equal to n in the collection of terms having highest degree of degree n and n minus 1 respectively. For example, if suppose if I take f of xy equal to x cube plus y cube minus 3axy is equal to 0. So for this example, what is highest degree? The highest degree is 3. It means we can calculate phi 3 of m. How we calculate phi 3 of m? Put x is equal to 1, y is equal to n in the terms having degree 3. So if I substitute x is 1, y is n, so there are two terms having degree 3. So we get 1 plus m cube. So phi 3 of m is equal to 1 plus m cube and its solution is m is equal to minus 1. How we get m is equal to minus 1? 1 plus m cube is equal to 0. This implies m cube is minus 1 and which implies m is minus 1. Now the constant c can be calculated by using this formula where value of m is 3. So it will become c is equal to minus phi 2 of m divided by phi dash 3 of m and which is equal to minus as it is. Now phi dash 3 of m, what is phi 3 of m? It is 1 plus m cube. Therefore phi dash means its derivative. And what is its derivative? It is 3m square. And phi 2 of m can be obtained by putting x is equal to 1 and y is equal to n in the terms having degree 2. So there is only one term having degree 2. So that is minus 3axy. Put x is 1, y is m, then we will get minus 3am. So that I have substituted here. And when we simplify this, the value of c, you will get it as a upon m, but value of m is minus 1 and therefore value of c is minus a. And therefore the oblique asymptote for the given curve is y is equal to mx plus c, but value of m is minus 1 and value of c is minus a. Therefore the oblique asymptote is y is equal to minus x minus a. And this implies x plus y plus a is equal to 0. So this is the oblique asymptote.